Okay, see. So the two misconceptions are clear to you. The first, which is mentioned, that light year is commonly understood as a unit of time. So we saw in the last class that light year is not a unit of time; it is a distance traveled by light in 1 year.
Yes.
So we didn't exactly calculate the value of it, but we saw how to calculate the value of it. So actually, what the calculation, if you do, it will be 9.46 into 10 to the power 15 meters. If you calculate the thing that we had written the last time. Okay.
So your volume is quite low.
Okay. Now is it better if I speak a little louder?
It's almost the same.
So is your laptop volume full?
Yeah, completely full.
Okay. Now is it better?
Yeah, better. Now better.
Okay. 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 There are still people sleeping around me, so therefore. Anyway, so the second misconception is that 1 kg equals to 1 liter for all liquids. So how 1 kg is not equal to 1 liter? That 1 kg resembles what? 1 kg resembles mass.
Weight, mass.
Not weight, mass exactly. In the last class, if I didn't tell you, you should note that weight is basically a kind of force. Okay. I think I had mentioned this or not. Weight. If not, write it down. That weight equals to mass into g.
You haven't mentioned it.
Okay. Okay. You write it down. Weight equals to mass into g.
Yes.
And the value of g is
9.8.
yes. So consider that there's a block of mass 10 kg. What will be the weight of this?
It would be 98 kgs.
Yeah. And the unit would be what? See, again, it's not kg. Mass is 10 kg. 10 kg multiplied by 9.8 meter per second square. I had told the gravity is acceleration.
Yes.
So kg meter per second square means basically mass multiplied by acceleration. And that is the unit of force.
Force. Yes.
So therefore, it will be 98 Newton, capital N.
Okay.
Okay. So 1 kg here is mass and it is equals to 1 liter. So they two have no comparison because kg is mass and liter is volume. But they are related. How? They are related through density. So density is equals to mass by volume.
Yes.
Okay.
Yeah.
So 1 kg may be equal to 1 liter or may not be equal to 1 liter also. I will tell you how today. More in details we'll learn. During conversion, we will see this. And second, in the answer it is written, mass of liquid can be measured in kg. Yeah, mass can be measured in kg and the volume is always measured in liters. We'll see other units of measuring volume as well. So we had discussed these things. Okay, so this is another thing you just have to remember that there are three system of measurements. You're able to see my screen, right?
Yes, sir.
There are three system of measurements. Just have to remember. One is FPS, CGS, and MKS. So FPS stands for foot pound second. Okay.
Yeah.
And you should write it down. I'm telling you certain important things. Foot pound second. 1 foot is 0.3 meters approximately. You can try to remember if possible, although it's not very important. 1 foot is equals to 0.3 meters roughly. 1 pound is 0.45 kg. That's it. Okay.
Yeah.
So generally, when they in the Western countries, when they have to measure weight, then they usually measured in terms of pounds, or they measure height
Yes.
in terms of foot. In India, we generally use MKS system, that is meter, kilogram, second.
Second.
And
Yes.
this is also which we have been referring for so long as the SI unit.
SIU.
Yeah.
Yes.
And the center one is CGS, that is centigram, centimeter, gram, and second. Okay.
Yeah.
So these are the three main systems. and we are supposed to know the conversion from one system to another. So again, we don't have to remember the things. We'll understand the things in today's class, how to do that one by one. We'll take many examples. Fundamental and derived quantities we have already discussed. Okay, now you see here it is mentioned length of a fundamental quantity. Yeah, now length can be measured in different units. I'll show you now certain things. Wait. So before going to that, just see here it is written length can be, the last line of the first paragraph is length can be measured using devices like a meter scale. Now what is a meter scale? Meter scale is basically a scale which is like the ruler which you use to draw lines. It is calibrated in terms of centimeters. Calibrated means the marks which are there, it's called
Marks.
calibration. It's there as centimeters only. Okay.
Yes.
So meaning of meter scale is, 1 meter length. It's a scale of 1 meter. Okay. So whenever it is mentioned a meter scale, you have to understand that what is the length of meter scale?
1.
1 meter. Very good. So just note down somewhere meter scale. One essential thing about meter scale is its length is 1 meter. That's the first thing. Note it down. I
Yeah.
can also annotate here. 1 minute. Yeah. So first thing about meter scale, length is in total 1 meter, and the smallest unit which meter scale can measure is 1 millimeter. If you have your scale, you will see that the scale usually measures up to 15 centimeters. The ruler which you have right now,
Yes.
and it is divided like 1, 2, 3, 4, 5, and so on. And these are centimeter: 1 centimeter, 2 centimeter, 3 centimeter, 4, 5, and so on. And actually, every 10 centimeter is further divided into 5 parts. 10 parts. You have seen 1, 2, 3,
Yes.
4, 5, 1, 2, 3, 4, like that. Huh?
Yeah.
So the smallest unit which you can measure is this
1
one
millimeter.
1 millimeter. Very good. You understood?
Yeah.
So this is the smallest, the most accurate length which the meter scale can measure is 1 millimeter. So if you have an object of 1 millimeter also, you can measure its length using meter scale. So there was a necessity of measuring certain values to a higher accuracy. It was required. Say for example, I want to measure something more accurately than 1 millimeter. Say 1.5 millimeter. Can you measure that using a scale? See, you
No.
can measure 1.5 centimeter. You can measure,
Yeah.
right?
Yes.
But can we measure 1.55 centimeter?
No.
Yeah, we can't. We can measure either 1.5
Or 1.6.
or 1.6, but this we can't measure. So for this, we have another instrument which is called vernier caliper. You ever
No.
seen this vernier caliper?
No.
Uh, I'll show you a picture of it. Okay, I hope now my screen is visible too. My screen is visible, right?
Yes, sir.
So I'm searching for vernier caliper. You see, yeah, this is a vernier caliper. It's like this, right hand side.
Yeah.
So in this, you see there are. It's something. How do you call it? It's like the two thing which is holding that black thing in between.
Yes.
It can be
Yes.
spread apart.
Yes.
Okay, it can be spread apart. And you can see there are two scales. One is the meter scale, the gray one. As you can see, the
Yes.
ruler which you have in your home, it's like fixed. So that part
Yeah.
is fixed. And the where is this? And the second scale which is there, I'll show you. So this is known as meter scale. Usually, with what we have, the meter scale, and the other scale, this is called vernier scale. It's special for a vernier caliper. And this is another scale. It's a very special scale, and this is movable. So this portion which I'm marking as red, this portion is entirely movable. This one, okay? Means you can put your hand on that and you can just drag it on the right hand side. We do this experiment in our class 11th.
Oh.
And you put something in between and you can, the value which you will get, it will be accurate up to 2 decimal places, like say 2.56 centimeter, like that, or 2. 5 8 centimeter like that. You can measure it. So how to measure it? I'm not going into it. But the point is vernier caliper. Its use is what you understood
Yes.
to measure accurately up to 2 decimal places. So the smallest unit that this can measure is 0.1 millimeters. Usually meter scale measures 1 millimeters, right?
Yeah.
But this can measure the smallest unit as 0.1 millimeter.
0.01 isn't possible because 2 decimal places.
What 0.01?
01
What you're asking 0.01 is?
cannot be measured in this because 2 decimal places, up to 2 decimal places we can measure, right?
Yes. So basically, see, when I'm mentioning millimeters, then don't be confused. 0.01 I mean 0.1 millimeter means
Millimeter is okay.
0.1 millimeters means 0.01 centimeter.
1 centimeter.
This can be measured, okay?
Okay.
In terms of centimeters.
Yes.
So 0.1 centimeter, so anyhow can be measured using normal ruler.
Yes.
This can measure 0.01 centimeter also, okay?
Okay.
Yeah. And something more I wanted to tell, yes. So you have to write a specific term in your copy, write down. There is something word called least count. Least count is the smallest length that can be measured by an instrument, the specific term. The smallest length that can be measured by an instrument. That can be measured by an instrument, okay? So least count for an instrument, it's defined for an instrument. So say for example, I ask you, what is the least count of a meter scale?
1 millimeter.
It's 1 millimeter. And least count of a vernier caliper?
0.01.
0.1 millimeter or 0.01 centimeter.
0.01 centimeter and 0.1 mm.
Clear?
Yes.
That is called vernier caliper. There is one more instrument, it's called screw gauge. Just write it down. One more thing. One more instrument. It's not mentioned there, I guess.
Yeah, it isn't.
Not mentioned. So write down there is another instrument, SCREW, screw gauge. GAUGE. Let me check if the picture of that is screw gauge. Screw. So this is basically called a screw gauge. So this is even more accurate than vernier caliper. So again, it's working. We are not going into the details. Speciality about screw gauge is that it can measure 0.01 millimeter.
Okay.
It is even more precise than vernier caliper. Okay. See, least count. It's 0.01 millimeter. Clear?
Yeah, it's given in the fourth figure.
Correct. So this is 0.01 millimeter. Okay. So now let us come back to the PDF. So you have understood the, yeah, my screen is visible. The PDF is back visible, I guess.
Yes, sir.
So measuring tape is a Indian style measurement, which it's like a meter scale only.
Yeah.
Okay. So these are the different instruments with which we can measure length. And it's mentioned the ruler can measure up to 1 millimeter. Yeah, it's fine. Least count of, it's mentioned, least count of ruler is 1 millimeter. And least count is defined for a particular instrument as a minimum amount of length that it can measure. Yeah. So these things, I hope you can understand on your own. It's very easy.
Yes.
So now we'll be skipping a little fast. You have read these things on your own?
Yeah.
Okay, so you understood this, that thread thing?
Yes, sir.
Okay, then divider thing you have understood?
Yeah.
Okay. So this diameter thing, how to calculate diameter of wire you have understood?
The formula is quite not clear for me.
Okay. See, say for example, I have a pencil and I have to measure the diameter of the wire. Understand the diameter of wire? I have this wire, that is the laptop charger in front of me. The diameter of this wire is what? It's very less. Diameter of the wire, you understand this much thickness of this.
Okay.
It's the wire is cylindrical, no? Whether you take the
Yeah.
wire of a charger, whether you take the wire of a laptop or PC or anything, it's cylindrical basically, right? So how to measure the
Yeah.
thickness of that? To measure the thickness of this using scale is also possible. If you have a scale, you can measure it. But there is another method also. So what they do is that, say for example, I don't know, you're able to, yeah, you're able to see my screen. I mean, me here.
Yes.
Say for example, I take this and I wrap it around. I can't wrap it; it's a really thick wire. If something thinner wire is there, yeah, this is my earphone. So you see, I wrap this around my like this finger. Okay.
Okay.
So if you carefully see how many turns are here,
3.
say for example, I take it very close to them. I mean, I keep it like this. Yeah. So in total, how many turns? 3 turns, right?
3. Yeah, 3.
Yeah. Now this length I can measure easily using a scale. It will be more convenient
Okay.
for me. Clear now?
Yeah.
So I
Yes.
wrap this over the scale and I measure this length.
Hmm.
And this length is basically number of turns multiplied by the diameter of the wire.
Okay.
You're getting? This is the thickness of the wire, no?
Yes. Yes.
Clear?
Yes.
So that length is what? Number of turns multiplied by the diameter of the wire. So from
So
there you
then
can get the
we can
diameter.
divide it by 3.
Yeah. Clear now?
Yes. Clear.
That formula is mentioned. The diameter of the length of AB is diameter of wire multiplied by the number of turns.
Okay.
So from there we get the diameter. It's basically it's not scientific method. It's a jugaadu. I mean, what do you call it? Jugaadu method. You understand, no?
Yes.
Just invented it like that. Yeah. These are not standard method. It's all common sense.
Yeah.
Okay. So length is clear. Let us go to area. In area, this specific section was clear. How they measured the area of this.
Yeah.
Yeah. Now this will be highly inaccurate. There is no guarantee of its accuracy.
Very inaccurate. Yes.
But still they have given for the sake of giving that. So now measurement of volume. Okay, so here something is essential. Okay, these conversions I'll be telling you in greater details right now. But first let's cover this entire thing. Okay, again, so here 4 instruments are given. So this is called measuring cylinder on the left hand side you see. So it's nothing. The labelings is already done. Water is filled. As much amount of water we need, we just take it. So measuring cylinder. There is something called measuring flask. So for a measuring flask also, it's not mentioned there, but the labelings are given. So we
Okay.
take as much amount of water that is needed. It's called a measuring flask. Or specifically, say for example, a measuring flask also can be of a specific volume, say 500 ml, 200 ml, and it will be marked like you have some, like here's a bottle. Okay, so measuring flask means here it will be marked 500 ml. So you have to fill the chemical up to 500 ml. You'll get that. That's a measuring flask. Then the third one is called pipette. Pipette means what? Uh, you have seen that when they play Holi, what is that called? Pichkari.
Yeah.
Yeah. So it's something like that. We pull the water, I mean the chemicals using our mouth. We put our mouth on the top hole. Then that go. It's called pipette. I know these are boring things, but still, because it's given, I'm just covering it.
Yeah.
So here you put your mouth and we pull the chemical. So this is dipped in a vessel like this, filled with chemicals, and we
Yeah.
suck. So it goes up to here, say for example. Okay. We
Yeah.
don't suck it so heavily that it enters the mouth. I remember it's a serious experiment with like we sometimes have to draw acids like hydrochloric acid or something. Of course, they are not concentrated; they are diluted. But still, we are asked that you have to draw very carefully because it can enter the mouth. अगर ज़्यादा जोश में खींचेंगे तो.
Yeah.
So we draw it slowly, and then say it is little more. Say up to here we wanted. It went little more. Then you can so after drawing we cover it using our finger here, so it gets blocked. It won't. So even if there is a hole here, it won't come out actually.
Okay.
And
So
after
there's one more thing, just like the pipette, like we can press it with our finger and the water or acid gets up.
that is called a dropper. I think that is what we are mentioning. It has say it is something like that. It's like here it is some spongy thing on the top. That's what you're mentioning.
Yes. Yes. Yes.
Yeah. So when we so yes, so we press it first. So all the air actually comes out of here, and then we put it in some liquid, and then you release this upper thing which you have pressed. You just release it. So once you release it, due to air pressure, the air pressure pushes this liquid, and the liquid goes inside.
Yes.
Yeah, so this is basically called a dropper. It's used when you take I mean, I've seen it, I've used this also, but I forgot where I used it. It's a very simple thing to use. You can go and purchase it in the market only. In market
Yes.
also it is available. Just take it, first push it like that. Okay. Yeah. And the last one is burette. So burette is also somewhat like pipette. You fill the uh, some chemical up to a certain point. Say for example, you fill it up to here. And the difference between pipette and burette is pipette is a manually operated thing. Manually means we release our, like it's like we keep on pressing our hand at the top. If we have to release the liquid, we move our hand up and again we press so that the liquid gets stopped from coming out.
Yes.
And burette is automated mechanism. Here is a cork that is fit. It's called a pitch cork. Somebody has written. You have written or what?
This is a book which is used by my sister also.
Okay,
so
okay.
I'm using the same.
Yeah. So here is a cork which is fitted actually. So this cork stops it. There is a knob. It's like you have seen filter, no?
Yes.
We block the water coming out, and then when we lose it, water comes out. So it's something like that. So it's a more finer mechanism than pipette. It's called a burette. Okay. So these are the 4 ways in which we basically measure the different quantities of water. Or, I mean chemicals, not water. Okay. Yeah. So then different things are given: measuring jar, flask, pipette, burette. Yeah. Now let us come to how to measure the volume of irregular solids. You understood this?
Yeah.
Everyone?
Yes.
Okay. Then I'll move ahead. Shall I move ahead to measurement of mass?
One thing I didn't understand. The second one what they've given isn't clear.
Second one, huh? A single drop of water. Take a clean burette with water, clamp it upright, remove any air bubbles formed. Now allow water to trickle slowly drop by drop. Count number of drops when known volume of water has been drained out. Yeah. So say for example, I want to measure what is the volume of one drop of water. It's very small. How will you measure? So therefore, what do they do? You're getting first the what is the point? What I'm supposed to measure is clear?
Yeah. Single drop of water.
Single drop of water. So what they do, they take a burette, something like this. And now in this burette, now from this burette, what they do? They take a flask, say a measuring flask or something in which I can measure the amount of water. So here it's mentioned, say 10 ml or 5 ml. The calibration is already done. Not 10, say for example, let's take 5 ml. Okay. Now what they do, drop by drop, they drop from here. It's a burette, so you have a mechanism. A cork is fitted or a knob is fitted, whatever you call it. And they move the knob so slowly that one drop of water only comes. Like that you can do using a filter also.
Okay.
You have seen when you move filter little bit, one drop tap, tap, tap like that it comes.
Yeah.
Yeah. So like that, what do they do? They drop amount of water to such an extent that it gets filled up to 5 ml. Say for example, there is no hard and fast that you have to take 5 ml. But suppose they count the number of drops. Say n drops have fallen.
Okay.
After n drops fallen, I measured the quantity as 5 ml. So what is the volume of one drop? 5 ml.
The n by 5 ml by n drop.
That's what they have done. Volume of water drained out by the number of drops.
Oh.
Okay, so that's how you measure the size of one drop. And of course, it may vary depending on the size of the hole from which the drop is coming out. If the size of the hole is small, maybe small droplets will come out. If it's large, maybe little large droplets will come out. Okay. So this is how we can measure the size of one drop of water. Okay, let us move ahead.
And sir, in the third one, what is a lead shot? The next one.
Lead shot. It's like bullet shot. You have heard? Pieces of bullet. So lead shot means spherical. Spherical lead pieces.
Oh.
You understood lead shot means?
Not so clearly.
Bullet,
It could be some like spherical. I'm not understanding.
Laddu, you understand laddu, na?
Yes.
Lead shot means Laddu not made up of laddu, laddu made up of lead, metal.
Okay.
They are called lead shots. Spherical objects are called basically shots, like gulab jamun shots, rasgulla
Okay.
shots. So it's lead
Okay.
shots in small, small pieces of lead. So we may want to measure their volume. So this is how they are measured. Okay,
Yeah.
lead shots. Yeah, and they have to be of the same size, everyone. Then only we can divide by n. ऐसा नहीं कि one lead you take this big, then another lead shot is this big, then this big. No. Then only we can divide by n, right?
Yeah.
So
Yes.
it's like that.
Got. And sir, in the first one B, uh, first one B, the what is sinker? I didn't understand.
Okay, they have what they have done now. Say for example, there is a uh, there is something which floats on water. So we need to measure the volume of it, right?
Yeah.
So the problem is that it's not fully sinking. If it fully
Yes.
sinks, then the water level that will rise will be its volume, correct?
Hmm.
So what is happening? There is something very heavy which will 100% sink in the water. It's
Oh,
like something like an anchor for a ship. Just put it in
okay.
water, it will sink 100%. Correct? Okay. So the first
Okay.
step they have done it that they have immersed sink already in the water, and they have
Okay.
measured the level of the water as V1.
V1. Yes.
This is with sink included.
Hmm.
This is not just the level of water, but water with sink. Okay. Now in the
Okay.
second step, what they have done, they have inserted. Now they have tied that unsinkable thing to the sinker. Means this fellow sink to डूबेगा ही और इसको साथ लेके डूबेगा.
Okay.
You understood?
Yeah, I understood.
Yeah. So now after the sink and both of them are sinking. So it's called forcefully sinking that thing. They're forcefully sinking it
Yes.
using a sinker. And then the volume they have measured is V2. So exclusively then the volume of that unsinkable object will be V2 minus V1.
Yeah. Got it.
And there will be some error in this. Whatever the connection part, उसका अलग से volume आएगा, but the connection is negligible if you use a thread. Thread has almost negligible volume. Okay, shall we move ahead to the measurement of mass?
Yes.
So, okay, here it is written. Weight is the force with which the Earth pulls the body towards its center. Okay. So there are different kinds of balances. One common balance, physical balance, beam balance. There are different kinds of balance, and I checked the internet. All of them look quite alike only. Okay. So almost all of them look quite alike. They're known by different names. If you go to the market, to the shop for purchasing some vegetable, they have a physical balance. They hold it like this, and there are, two
Hmm.
trays kept here. Similarly, physical balance is also something like that only. But physical balance is a bit more accurate. So this part I will check precisely, and then only I will tell you. Okay. That if we
Okay.
already have a physical balance, then why we need a common balance at all? Why we need a beam balance at all? Because I once went through it, but I couldn't get a very clear picture of it. And there is another thing which is a digital weighing machine. Sometimes today, these days, when you go to shop, if you have to purchase a 500 gram sugar, 1 gram sugar, you put that sugar on that balance. And there's a digital, you have seen, like 1.00 it shows. I don't know if you have seen or not. You have not seen? You have not gone to shops?
I haven't. Yeah, I have seen the digital balance. It's
And
somewhat like a weighing machine.
somewhat like a weighing machine. Yeah, it is actually a weighing machine only.
Yes.
You just put something on it and it will show you 2.345 kg, something like that. It's a digital. So
Yes.
so internally it measures weight by a spring mechanism.
Okay.
Just this much you understand. It measures the weight. अच्छा नीचे लिखा हुआ है नहीं लिखा है. It measures the weight by spring mechanism. So if you want to know details about it more, we'll discuss that at the end of the class. Okay. Yeah. I'll just tell you once. Wait. I hope my screen is visible now. I've opened
Yeah.
one. See what is spring mechanism. I'll just show you quickly. There are springs known to us. Okay. I'm writing something. It's visible now.
Yes, it's visible.
Okay. There are certain springs that are known to us. What is the meaning of that? See, every spring which is there, there's one spring, there's another spring. So there are different kinds of springs available in the market. You can go and check. Now, Every spring has a specific constant which is known as spring constant. Every spring has a specific constant known as a spring constant, and it is denoted by K.
Okay.
It basically gives us an estimate of how difficult it is to pull the springs apart.
Okay.
It gives us a estimation of how easy or how difficult basically it is to pull the ends apart. To pull the ends apart. Okay. So if this has a spring constant of say 100 and this has a spring constant of 80, which string is more difficult to extend?
100.
Yeah, 100. So now what they do, now this is known to us. It's known as spring constant because it is constant for a spring. Therefore, it is known as a spring constant, this term which we have used. So now what happens? Say for example, I have a spring hung like it, like this, okay? And on one end of a spring, I have put up a mass. Say the mass is m kg, okay? And the spring constant, say it's k. So naturally, if you have a ceiling and from that there you hang the spring vertically and fix a mass at the bottom of the spring, there will be some extension in the spring, right?
Yeah.
It will pull the spring down and come at rest finally. Eventually, it will come at rest. So say for example, spring initially was somewhat like this. Okay, it was initially like this. And now this much it has got extended. Let
Yes.
this be x. Okay.
Okay.
So just focus on the right hand side once. Whenever I extend a spring by a length of x more than its natural length, when there is an extension in the spring of x, then spring pulls that object towards itself. It's logical, right? If you
Hmm.
extend a spring, then it will try to pull you back towards its natural length.
Yes.
And if you compress a spring, it will try to push outward. Springs
Hmm.
naturally always try to regain its natural length.
Hmm.
So whenever there is an extension of x or a compression of x, the force exerted by the spring is called spring force, and the value of that is k into x. It's simple value, k into x, where k is the spring constant and x is the extension.
Okay.
Clear? The simple formula, nothing more than that. And the unit is going to be newtons because it's spring force ultimately.
Okay.
So now you look on the left hand side diagram. If I consider this mass m here, there are two forces acting on this mass. One mg in the downward direction, which the earth is pulling it,
Hmm.
and in upward, because the spring is extended, it will exert a force upward. How much?
K.
Kx. Okay. Now, because this mass is at rest, the above and the bottom forces must be equal. Got it?
Yes. So,
Clear now?
yes. Clear.
Now, say for example, I don't know this mass, how much this mass is. I don't know what is the mass of it. But using scale, I can check the extension, right?
Yes.
This can be found experimentally. And K is known to me because I have chosen the spring. K is known. Clear?
Yes.
So here mass can be found Kx by G.
Okay.
K is known to me. X I can take it down and G is 9.8. So I can find the value of mass. You got it?
Okay.
So internally those digital weighing machines have a spring fitted inside it. So they put something on top of it. The spring gets compressed. And when it gets compressed, X is calculated internally. K for the spring is known. So internally, there is a calculator inside that machine which gives the value of kx by g and displays it to you.
Okay.
It's clear how they measure this mass?
Yes, and even the weighing machine is also the same, sir.
Of course, if it is digital, then all of them have to follow the same pattern.
Okay.
Yeah, weighing machine is also digital. I'm sorry, what I'm saying. Yeah, of course. That also measures using the same principle.
Yes.
Okay, there are springs inside it, and that's how they give you the value of X.
Yeah.
Yeah. Okay, let us go ahead now. Okay, so we have completed this. Now it is said the weight is third paragraph. If you see, first two paragraph is I hope clear. Third paragraph is the weight is generally measured in kilogram. Sorry, the weight is generally measured in kilogram force. So kilogram force is newtons.
Yes.
Kilogram force is newtons, and there is something called gram force. So the unit of Newton is kg meter per second square, right?
Yes.
And there is gram force. Gram force means gram per meter second square.
Okay.
Okay,
Okay.
sure.
Yeah.
Yeah. So 1 kg force or 1 kilogram force is the force exerted by Earth on 1 kg object. So 1 kg multiplied by acceleration due to gravity. And 1 gram force is the force with which Earth attracts a body of 1 gram. So how much that will be, we will just check once. So 1 kg force is clear, I guess. 1 kgf is how much? In Newton, it will be 1 kg multiplied by 9.8 meter per second square.
Yes.
This is the weight.
Yes.
Okay, it's called 1 kgf. And there is something called 1 gram force. So the force with which Earth attracts 1 gram. So it is 10 to the power minus 3 kg multiplied by 9.8 meter per second square. So this is it.
Or else we can do 1 gram into 9 point.
So we can do 1 gram into, then usually see, either we will use MKS unit, which we have used above,
Yes.
or we'll have to use CGS. So because gram is here, then you have to convert this as 980 centimeter per second.
Okay.
9.8 meter is clear, no? 980 centimeter per second.
Yes. Yes.
So this will give me 980 gram centimeter per second square. Clear?
Yes.
Okay. So 1 kgf is also known as 1 Newton, technically speaking, and 1 gram force is known as 1 dyne, dyna. This is basically 1 dyne, dyna. Okay. Is it clear?
Yeah. Clear.
Okay. So this much you understand, because these are the things that we are not supposed to mug up, but yes, we are supposed to understand. So the important lesson from here you have to understand is you have to keep the calculations either fully in MKS or fully in CGS,
Easy.
not in between. Okay.
Yeah.
All right. SI unit of weight is Newton. The amount of force acting on a body when the Earth pulls a mass 100 gram is equals to 1 Newton. Okay. Shall I define how to? Okay, I'll teach you this how to define terms, because here the definition is given. I'll show you. You have copied this left hand side.
Yes.
Then I'm rubbing it. Now I'm going to show you certain. These are theory things you have to understand. Okay. But this theory will be helpful for you in any classes from now onwards.
Mm.
So I'm going to show you how to define different terms. See, how do you write the definitions? And this is very important. Write down definitions. So actually, how do we define? Say, for example, I'm supposed to define 1 kg meter per second. Okay. Kg meter per second is the unit of what? Momentum. mass into velocity. You remember?
Yeah.
So how 1 kg meter per second I will define, it's just a matter of English. We will define it. The momentum acquired by a body, just first listen carefully, you'll understand it. Then you have to tell 2, 3, then you can write it down, okay? So 1 kg meter per second, how I will define? The momentum of a body of mass, how much? 1 kg moving with 1 meter per second. Simple. Okay? This is
Moving
momentum.
with speed of 1 meter per second.
Yeah, 1 meter per second. Because momentum is mass multiplied by velocity. So mass is how much? Now I have to keep on the left hand side 1, right? That's what is the definition is asking for. You define 1 kg meter per second. Okay?
Yes.
It's not asking me define 2 kg meter per second. If the definition would have been defined 2 kg meter per second, what would we have said? It is
The momentum of the body of mass 2 kg with the speed of 1 meter per second.
very good. Like that. Clear?
Yes.
Or we can also say it is the momentum of a body of mass 1 kg moving with 2 meter per second. Like that also.
Okay.
Got it now?
Yes, got it.
That's how that's how these particular terms are defined. Whenever it's one given and you know the formula, so you put everything in the formula as one on, and you write it down just in English proper. That's it. Okay, so then mass was 1 kg. So in the left hand side, because it is 1, so 1 kg multiplied by it is 1 meter per second, like that. On the left hand side, just keep 1. Right hand side, all the terms just put it as 1, 1, 1, like. So now there's a standard definition. Say for example, you have to define 1 Newton. Now this definition comes in 11th. This definition comes in 11th, and like that, many definitions will come. Provided if you have understood, you can define it very easily. So how you can define 1 Newton? So you have to refer back to the formula for force. 1 Newton is force.
Mass into acceleration.
Very good. So what will the definition be of 1 Newton? See, this is 1 Newton
The
means
force of a body of mass 1 kg and at this we're getting how further to define.
yeah, you basically understood just now. You have to twist the English somehow and you have to fit it in the sentence.
Yes.
The simple thing is the mass is going to be 1 kg and the acceleration is going to be how much?
Meter per second square.
This much. Now I also don't know the definition, but I know how to frame it. So how I will frame it? So I'll say that 1 Newton force is the force required to move a body of mass 1 kg with 1 meter per second square.
Okay.
It's a proper definition. It's an authentic definition.
Yes.
So we don't have to remember it also. But 100 times, I'm 100% sure it will be asked to you. Not in Olympiad, but I'm just telling you how to define so that tomorrow when you read books, you can understand how the definition is written. It's clear now how 1 Newton was defined?
Yes.
So you can write down in your own words. Now say for example, I tell you define 1 Pascal. 1 Pascal you have to define. So you take your time and write it in your words and then you can dictate it to me. 1 Newton I'm writing. Once you're done, you can let. Done?
Yes, done.
Okay. Tell what is it?
1 second. The pressure used to used to move or measure? That's I'm getting confused.
Okay, what is the formula you have used for 1 Pascal?
1 Pascal is force by area.
Yeah, so 1 Newton by 1 meter square.
1 meter square, yes.
Okay, so pressure is now, see, you have to first of all get a hint of how to start the definition, because like force, so force is exerted, okay, and it moves an object. So that's how I had that's how we started. Force required to move,
Okay.
and here it is pressure. So pressure is also exerted.
Force, okay.
So how you will start the definition? 1
The
Pascal is the
1 Pascal is the force required to move an object. Not move.
just exerted. 1 Pascal is the pressure exerted.
1 Pascal is the pressure exerted for a body with 1 Newton force and area in meters square.
See, you'll write 1 Pascal is the pressure exerted by a force of 1 Newton on 1 meter square.
On 1.
That's it. Okay.
Yes.
So 1 Pascal, because pressure is exerted. So 1 Pascal is the pressure exerted. And who exerts pressure? Force. So 1 Pascal is a pressure exerted by 1 Newton force on an area of 1 meter square. Simple. You got it? It's clear to you? Shall we move ahead? I think you are mute. Your voice is not coming.
I'm writing it down.
Okay, okay, okay. Write it down.
So can you move up to that kg meter per second? Yes.
So once you write copy the last point, you let me know. First I'll explain, then you quickly copy it. Go ahead first. Cover this today.
Have to write down both for the Pascal?
Actually, you don't have to write both. The second one, you can write it down, but I'll just explain. The first part you have written.
Yes.
Okay, the second part, if you look, is it correct or not? That 1 Pascal is a pressure exerted by 15 Newton force when applied on an area of 15 meter square. So mathematically, is it correct?
No.
Sure. Check once.
Yes. 1 second. It is correct.
Mathematically, it's right only, right?
Yes.
With 15 Newton, if you apply on 15 meters square, they get cancelled and
Cancel to
one.
1. So 1 is correct.
But this definition is not the standard definition. Like that to anybody, like, there are 30 students in a class, they'll give 30 values.
Yes.
So definition has to be 1. So therefore, on the right hand side, we always mention 1, 1, 1 like that. Okay.
Okay.
It is a standard. Now, why I wrote this definition? Because in this book, that definition is given. I'll show you. In book, what is given? The amount of force acting on a body when the earth pulls a mass of 100 gram is equal to 1 Newton. This definition you don't have to remember at all. It's not a standard definition of 1 Newton. Just for the sake of writing, it has mentioned. You got it?
Yes.
It is not a standard definition. It's not a definition. Don't remember this thing. 1 Newton definition we have already studied. 1 Newton is a force which produces an acceleration of 1 meter per second square when applied on an object of mass 1 kg. Then why this definition is given? So mathematically, it's not wrong. Mathematically, if you see, amount of force acting on a body when the earth pulls a mass of 100 gram. So 100 gram force is pulled with how much? And like 100 gram is how much?
0.1 kg.
0.1 kg. So earth will pull with how much? Multiplied by
98.
Meter per second square. So
No, 98.1. Yeah, that's correct.
so how much it is coming? 0.98 newtons. Okay.
Yes.
So roughly it is like 1 Newton. So that is how they have defined 1 Newton.
Yes.
Not the definition. Clear?
Yeah.
So it is just, but you have to understand that, okay, this is how mathematically they are trying to tell this thing. Clear, no?
Yeah, clear.
And how they got to this 100 gram, actually what they are trying to do, see, weight equals to mass into g, right?
Yes.
So if you anyhow have to put a say 9.8 meter per second square, somebody has taken a vow, I'll not write g, I'll not write acceleration as 1, I'll take it 9.8 only what the earth is pulling the object with. So in that case, then mass has to be adjusted, no, so that you get the value of weight as 1.
Yes.
So how you'll adjust this? You'll adjust this as 1 by 9.8, so that they get cancelled out and you get 1.
Cancel 1. Yes.
So this is 1 by 9.8 kg. So how much that is? 1000 by 9.8 grams. You got it?
Yeah.
And that is exactly 98.1 grams. Here it is mentioned.
Okay.
So that's how they have got it. So it's by force. But yeah, you have understood the calculation, how the maths part they have done.
Yes.
Yeah. So as per the definition, if you have to take that, the uh, the acceleration as 9.8 meter per second square, then so that will be certainly changed. The mass will be adjusted accordingly. Yeah, that. So let us quickly go ahead now. So this part is clear. Now measurement of time. Okay, measurement of time is pretty simple. There are two ways to measure time. One, you have seen the railway timetable. You have ever seen? It's like they show 15 hours, 30 minutes.
Yes. The 24-hour clock.
24-hour clock. So understand that? So or shall I discuss it?
I understand.
Understand? Very good. Then there is another kind of something like there is something called pendulum. Okay. So I'll give you a formula. So you have studied roots, root 2, root
Not
4.
much. This year I have it actually. From this year, 7th.
Okay, I also didn't check your Olympiad papers. I'll check it once. Okay, if it's not there, then still I'll just tell you one thing
Okay.
in order to understand. There is something called a seconds pendulum. It's a name of a pendulum.
Okay.
It's called a seconds pendulum. And before coming to pendulum, I'll just tell you certain things. This arrangement is basically called a pendulum. So this oscillates back and forth like this. Okay. Now this is an oscillatory motion. Okay. Now in any oscillatory motion, how do you measure the time period? For every oscillatory motion, there is something called a time period. And the time period is the period after which the motion repeats itself exactly in the same way.
Okay.
All right. So say for example, let us take one or two examples here. I will take one example. Say for example, you're dropping a ball. 10 second. Say this is height is 5 meters and it is dropped from here, the ball, okay? And this is a perfectly elastic floor. The meaning of perfectly elastic floor is that the velocity with which the ball will hit the floor, exactly that much velocity it will acquire after hitting in the backward direction.
Okay.
So this means generally you might have seen that if you drop a ball on the floor, does it comes back to the same height?
No, it
Yeah.
reduces.
It reduces because some energy is lost in the form of sound and heat when it hits the floor.
Okay.
So two energy losses. Sound is also a form of energy only. Therefore, if you keep shouting for 2 hours, you'll feel tired. You have lost some energy.
Yes.
Okay. So
Yes.
sound is a form of energy, heat is a form of energy. So therefore, in the last class, if I have not mentioned at this point, that SI unit of heat is also joules.
You have mentioned, sir.
Mentioned? Okay. One important point there, again, you write down wherever we had discussed this, or right now you write down. There are two units to measure heat usually. One is joules and another one is calorie, because later I might forget. And write down 1 calorie is 4.2 joules. It is essential. 1 calorie is 4.2 joules. There are two standard units to measure heat, either in calories
Two
or
standard units.
standard units. Yeah, standard means that is they are most widely used. Joules and calories. Joules we already have discussed, and another one is calorie. Calorie means 1 calorie is 4.2 joules. So calorie is greater than joule in terms of magnitude. Okay. This we very frequently use when we study calorimetry. Calorie. So it's like that. So yeah. So now why we are discussing, because whenever
4.2.
2 exactly 4.186, but roughly we take 4.2. Very precisely it's 4.186, but roughly we take 4.2.
Okay.
So whenever there is a collision, the energy is lost in two forms. One in the form of sound, one in the form of. Therefore, the ball doesn't reaches to its usual height. But here I have mentioned further, of course, atmospheric air is also there, so due to some air friction also doesn't reaches. But here the point is, it is given that elastic floor is there. Elastic floor means the velocity will be same after, I mean the bouncing, rebound velocity is the same.
Okay.
Perfectly elastic floor. There is something called perfectly elastic. There is something called perfectly inelastic. Perfectly inelastic means the ball will go and get stick to the floor only.
It won't even go up.
It won't even go up. Like you take atta ball. Atta you understand in Hindi? Dough. Okay.
Okay.
Perfectly inelastic collision it is called. Yeah. So now, if it rises to its natural height, okay. So I am mentioning to you at this point of time, you might not know the time taken from this height to come to here. If the ball is dropped, is 10 seconds. 10 seconds? No, no, no. Wait. Under. Sorry. Root under 2h by g. No? It will be 1 second. Sorry. In 1 second, it will come down. Okay.
5 meter in only 1 second.
Yeah, 5 meters is not too long. It will drop in 1 second only. Okay. Actually, the formula is root under 2h by g. The time taken to come to ground, this has the formula. If you have dropped it, so it is 10 by 10. Yeah, it will come out to be 1 second only.
Okay.
I'm also thinking we take only 1 second. See, seems less, but that's the point. Actually, if you take G 9.8, it will be little more than 1 second. Okay. Okay. So now you see what I'm trying to tell is that if you drop a ball from here, it will now you have to tell me the time period of this motion. Ball comes and rebounds, goes back to the same height. Now, once it reaches the same height, is it going to repeat its motion?
Yes.
So how much is the time period? The time period will be time to start from the starting position and go back to the original position.
It is
Now,
the same time period.
So what is the time period for this motion? If a question comes, the time period for this motion, how much is that?
One time up and one time down, right?
Yeah,
2 seconds.
so it is 2 seconds. Because after 2 seconds, it will repeat what it did previously.
Yes.
So the time period is defined in this fashion for any kind of a movement, not a pendulum. Whichever movement you take, say for example, I take a spring and I attach a block, and I pull the spring little bit here and I release it. So what will happen? The block will go back, will go forward, will go back, will go forward, will go back. Like this, it will keep happening.
Yes.
So time period for this is also defined. And what is the time? For a block to come from here back to here. And after that, whatever is this, so this is time period. And after that, again, it will be repetition.
Same. Yes.
That's how we define the time period. Now for pendulum, what will be the time period? You go
To
from,
go
boliye, boliye.
from A to C and back to A.
Okay, if I define from B, then what will I say?
From B to C, then from C to B, then from B to A.
And then again to B.
Again to B, yes.
Okay.
Yeah.
It's clear. So then again, the motion will repeat, right? See, it has gone here. Now it has come here. Is it repeating? No.
Yeah.
Because initially it started going towards right. Then again it goes till here. Is it repeating? No. Now it's starting from here. It has to start from here. Then it will repeat perfectly. So it will come back to here. So you can define the time period from any particular place. There is no hard and fast rule. In every situation, all three examples that we discussed, you can define time period from any place. But you just have to ensure you have covered the full one oscillation. It's called one oscillation. One oscillation means after which the body will repeat its motion. It's called one oscillation.
Okay. So one doubt in the pendulum, like it will reduce the speed casually, right?
It will reduce the speed. It's correct. In real life, it does reduces.
Yes.
But here, when we are dealing, we are assuming the conditions to be ideal.
Okay.
Ideal conditions means it's kept in vacuum. Means there is no air resistance. Okay.
Okay.
So then, in that case, it will continue to move in the same way eternally. Okay. Now let us move ahead a little fast. So see, we were defining seconds pendulum. From there, we went on to define time period and all that, and oscillatory motion. Little bit we saw. Now, seconds pendulum. What is that? If you take the length of the pendulum as 1 meter, this arm length.
Okay.
If you take this as 1 meter, and if you release it from any position, whether you release it from here, or whether you release it from here, or whether you release it from the position shown here, the time period is going to be same. That is an amazing fact. Okay.
But the distance will be a little much longer.
But the speed will also be more in that case, actually, of coming down.
Okay.
You're getting?
Yeah.
Yeah. Initially, you released it from C. But if you release it from a higher position, it will take some time certainly to come till C. But by the time it reaches C, its velocity will also be more. So in that way, it makes up.
Oh. Okay.
You're getting it?
Yeah. Get it.
Yes. So it's like that. Because I'll tell you the time period formula, write down for a simple pendulum. For a simple pendulum, not a seconds pendulum, this simple pendulum word. There is something called complicated pendulum also. It's not called complicated, it's called physical pendulum. But we are not going to discuss that. So for a simple pendulum, the time period is 2 pi root over L by G. All right. Write it down. It's 2 pi root over L by G.
What is L? Length?
Yeah, L is the length of the arm. Like here it was 1 meter.
Okay.
So it is the length of the thread for a simple pendulum. Simple pendulum means a thread and a bob at the end. You keep it hanging. That's called a simple pendulum.
Okay.
2 pi root over L by G. L is the arm length and G is the acceleration due to gravity.
Yeah.
So if you put the value of L as 1 meter, so this is 2 pi root over 1 by G, correct?
Yeah.
So G value is what, 9.8, no?
Yes.
Now remember, it's sometimes it helps in calculations that G is also pi square,
Oh, okay.
roughly. You can try it. 3.14 multiplied by 3.14, you will get roughly 9.8. I'll calculate it. 4 4 is 16, is that 12, 314, and 4 is at 12, 1, 4, then 9. Okay, I've done the calculations. 942, so what is it? 6, 9, 5, 8, 9. Yeah, you see, it's 9.8596.
9.596.
9.
9.8596. Yes.
Yes. Okay.
Yes.
So it's roughly 9.8, you see.
Yeah, 9.8.
So G value, sometimes you can remember it can be pi square. It will help in case you are dealing with pi somewhere or the other and there is a G also called.
So, like, can we scratch out, like, if the pi, we can't scratch, like, can we write pi as 1, pi as 2 and scratch out 9.8?
Yeah, what you're telling? We have to write pi as 2.
1 second, I'll just write and show.
I don't know how you will show. See you wait.
Like this?
How? Why you have written like that?
Pi I have written and scratched it out. It's scratch.
I didn't get it. What is the meaning of scratched?
Like I've written pi and
Uh,
scratched it out like this.
I'm not getting the purpose of it. I mean, scratched it out. What is that?
Like meaning simplifying it.
Okay. Okay. So why did you? Okay. Okay. Why did you cut it like 2 there?
Because pi square is g, right? So I made that 2 and g as 1.
Oh, no, 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 beta. Little small mistake. I'll show you. I understood what you did. Very good. Okay, now you can stop showing. I understood actually.
Okay.
Actually, that's what we are supposed to do, only what we have done. But we'll do it like this. See where it is. Here it was, see, 2 pi root over L. We have put 1.
Yeah.
L is 1 and G is pi square, correct? No?
Yes.
So this pi and this 2, you can't transfer it outside.
Okay.
Okay. So you have you have read this thing, 2 square is 2, this much.
Yeah.
This you understand, no?
Yes, yes, yes.
Okay. So what we will do, this is 2 pi. So also basically root under a by b is written as root under a by root under b. We can do like this.
Okay.
Means both can be separately dealt in roots, no issues.
Okay.
Okay. So this is 2 pi. I'm showing in detail. Root 1 by root pi square. Okay.
Okay.
So this is 2 pi. Root over 1 is what? It's 1.
1 only. Okay.
So 1 ones are 1. See, root over 4, why do we write 2? Because 4 is 2 into 2.
Yes.
So 2 times come now. So we remove 1
Yeah.
time, we just write 1 time outside.
1 into 1, we
Yes.
remove 1 and write.
And root over pi square is pi.
Yeah. Yeah.
So
Square
pi,
and root.
yeah.
And
So pi fully gets cancelled out.
so 2 into 1, so 2 is the answer.
Yes, 2 is the answer. 2 seconds.
Okay.
So time period for any simple pendulum is going to be 2 seconds.
Okay.
Is it clear or not?
Clear.
Yeah. So if it is given to you, say for example, I take a simple pendulum whose length is 19.6 meter. 19 divided by 2. Okay, this much. Say for example, I take a simple pendulum with a length of not 19.6. Let us take a length of 9.8 meters. So what will be the time period? Tell me quickly. Length of 9.8 meters. Write it as a question. Huh? Write it as a question. I mean, I'm doing little bit mess up here, but you write down the properly. Okay, it's a question. The length is 9.8 meters. Fast, 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 fast.
What is root of 9.8?
You won't need it.
Oh, I can scratch it out. 1 second, I'm getting it. So can I completely scratch it? Root of 9.8 and root of 9.8?
Because they will get cancelled, na?
Completely, okay. So
See, just
2
like
pi.
so 2 pi, that's it. So 2 pi seconds. That's the answer.
No need to write 6.28 seconds.
6 yeah, I mean, it depends on the options. You can write 6.28 also. That's not wrong. That's 100% correct. Okay.
Yeah.
See, just like sometimes you like 4 by 2, you write it as, you cancel and write as 2. Similarly, if it's in bracket 4 by 2, na, root over 4 by 2, you do similar calculations inside also. Inside also you can cancel out. You'll get 2. Clear?
What is root 2?
Uh-huh.
1?
Root of 2.
Yes, it's 1, right?
No, 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 no. It will be, see, root of 2 can't be 1. I mean, it's like, say, I'm writing root of 4. The logic is, it is root over 2 into 2. So whatever
Yes.
items will be duplicate inside, you can take it outside of the root.
Okay.
So 2 is duplicate, I'll take it outside. This is the answer. And that portion which you can't take out of root, you leave it inside the root only.
Okay.
There is
So
no
root
necessity.
2 only.
Yeah. So root 2 only. Say for example, 3 into 3 into 2 into 2. What will this be?
3 into 2, 6.
Very good. So that is 6. So this is 36. So root 36 is 6 because 6 into 6 is 36.
Yes.
But root over 2, you just leave it as it is. We can't take it out.
Okay.
But the value of this can be calculated. I think in which class it is taught, I don't know. The value of that is 1.414. There is a mechanism to calculate the value of it. Root 2, root 3, root 5, root 7, all this can be calculated. All right.
Yeah.
If possible, you can remember this value 1.414, standard value. Root 2, root 3 is 1.732. I don't know how you'll remember. It's too much. But I'm giving it from my end. Okay.
Yeah.
They're the standard values. Okay, so we have completed this portion. Now further, I'll tell you a little more thing about this time period factor because it can be asked 100%. I have no doubt about it because we teach time period anyhow in great details. Little more thing I'll tell you. See, time period, now put the heading factors affecting time period. Factors affecting the time period. What factors affect the time period of a pendulum? So I will write time period is 2 pi root over L by G, right?
Yes.
So what are the factors which are affecting the time period? Length of the pendulum and the acceleration due to gravity. These are the two things that affect the time period. Correct?
Yes.
Now, as far as length is concerned, can the length be changed? Say, for example, this is made up of uh, say it's a aluminium wire.
Okay.
or a steel wire or some metal wire. Okay.
Okay.
So this length actually can get changed provided you create a difference in temperature.
Yes, because of heat it gets
Because of
changed.
heat, it will vary. Yeah. So you
Yes.
know that if temperature, so how the length will vary, you see. So first is time period depends on length, and length varies with temperature. So write down length depends on temperature. Okay. So if the temperature is increased, length increases or decreases?
Decreases.
Increases. Very good. Okay. When the things are more heated, then the molecules inside the body get more energy, so they vibrate more fast.
Yes.
It's like, say, for example, 5 people, if you pack them and put them in hot summer sun, would they like to go apart or would they like to embrace each other?
Apart.
It's like because they'll start sweating and they'll feel disgusted and they will start
Yes.
pushing each other, go away, go away. Same thing happens somewhat with molecules. When they get heated away, when they get heated, the molecules gain more energy and they want to put other more apart. So they expand basically. All the
Yes.
metals, all the metals usually metal.
Expand on heating, contract on cooling.
Yes. So therefore, if say for example, I take this pen, like right now I measured a seconds pendulum in India. The answer was 2 seconds, right?
Yes.
Don't get confused. The name is seconds pendulum, but it time period is 2 seconds. Remember this.
Yes.
Okay. And if I take this pendulum in Antarctica, so will the time period be more or less?
Uh,
Previously it was 2 seconds. So there the time period will become more or less.
Less.
Very good. So write down. Okay. So in Antarctica, just write down this much. The time period reduces. And if I take it to Sahara Desert,
It increases.
it will increase. So this will vary. Now, okay, first let us complete this portion. So now let us talk of G. So if you take the second pendulum to moon planet, what will happen? In moon, the gravity,
Gravity is different.
yeah,
Is by 6.
1 by 6th. So because the gravity is 1 by 6th, the time period, what will happen? Increase or decrease?
Time period again decreases.
Check the formula. So see, G is in the denominator. If in a fraction you decrease the denominator,
The value increases.
yeah.
But
So if
it is as root, so I thought it is a bit.
no, it will decrease. See, if it is, say, for example, something is like root under 10 by 7, okay? So root over 10 by 7 has some value. If you make it
Yes.
root over 10 by 3, okay, no? So this is
Yeah.
naturally more actually,
More.
okay?
Yes.
Yeah. So the time period will increase if you go to moon. Means like previously it was 2 seconds, like it was going, then again the 2 second over. Now what will go in slow motion like this, and again it will come back. So it will become a bit slow. Understood? It might take 3 seconds, 4 seconds like that. Clear? Understood or not?
Understood. Clear.
All right. There is a urgency. Okay. The value of G is also clear. 2 pi root over L by G. Now what to do? Yes. Now there is another concept in pendulum itself. So far you have copied everything properly.
Yes, I've copied it.
Okay. Now say for example, if I tell you that time period reduces, there is another concept. If the time period increases, I'm writing this statement, I'll not ask. Time period increases, then time is lost by the pendulum. Then time is lost, we say.
Yes, time
Right.
is lost.
Okay. And if time period decreases, time is gained. Okay. Just write it
Yes.
down this much. Why time is lost? If time period increases, say for example, previously it was showing 1 second, 2 oscillations. Now one oscillation it is taking 4 seconds. So we are in illusion. We are thinking 2 seconds only has passed, but actually how much has passed?
4.
4 seconds, no?
Yes.
So we are losing time by 2 seconds.
Yes.
Yeah. Similarly, if time period decreases, like one oscillation should show 2 seconds, but one oscillation getting completed in 1.5 second only. So we are thinking 2 seconds have passed, but how much has passed only?
1 point.
1.5. So we are gaining 0.5 seconds in reality, right?
Yes.
So this much you have to understand. And further, इसके ऊपर calculations भी है, but that once I cover your syllabus, then I'll go through some advanced questions. There I will solve it. Okay.
Okay.
There can be more questions on this also, actually, individually. I'll take it. I'll myself give some questions to you at the end of this particular session.
Okay.
Okay. So density is mass by volume. Yeah. Now the basic conversion comes. Okay.
Yes.
So what do we do? I just ask you one question. Can you just wait for? Can we just start again our session from 12:40? Can you give me 20 minutes?
Yes, yes.
I
At
mean,
12:40, 20 minutes.
12:40 till 20 minutes will cover. Huh? In 20 minutes, we'll complete the chapter. Okay. Okay. Sound is not coming.
Like the class will extend until 12:40, you mean?
Okay. No, 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 no. There is an emergency call that has come to me.
Okay, okay,
So I
okay.
need to attend that.
Yes.
So if possible, can we start from 12:40 to complete it?
Yes, 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 sure.
If you are available, then how will I contact you?
I'll be in this meeting only. We both can be on mute. That's it.
Fine. So I'm leaving here only. Actually, I'll just attend this call,
Okay, sure.
and it might take me some time. There's a small work, and after that, I'll be back. Okay.
Sure. Okay.
Hare Krishna, Amulya, you're able to hear?
Yes, sir.
Sorry, there was a person who needed help. So I had to go. Okay, so we had discussed pendulum, right?
Yes.
And in pendulum, there can be one more question that can be asked. Period is 3 seconds. Yes, so one more special variety of question can be asked. I'm showing you how it is asked. So I'll just show you one example on this and more. I'll solve this for you and then we'll take some questions. When I'll give some personal questions to you, apart from the books, there I'll give you more questions on this format. Say, for example, a seconds pendulum is heated so that its time period becomes 2.5 seconds. So that its time period becomes 2.5 seconds. The question is find the time lost or gained in 1 week. Is the question.
Okay.
So I'll solve it. I'll show you.
Okay.
See, a seconds pendulum is heated. What do? You once think. Okay, let me tell first. Let me ask some questions and then with your help only we'll do it. The seconds pendulum is heated so that the new time period is 2.5 seconds.
Yes.
So the old time period was how much? It's a seconds pendulum. What was the original time period?
2.
Yeah, 2 seconds.
In a seconds pendulum, always time period will be 2 seconds.
We had calculated, no? Seconds pendulum.
Always.
Always means it's a name given to that pendulum. Seconds pendulum. It's a standard pendulum.
Okay.
Because that pendulum is a very special pendulum. You might have seen sometimes in movies also. It keeps on like it goes like this. So when it goes one way, 1 second is covered. Another way, 1 second is covered.
Yes.
So like it's half oscillation, 1 second, half oscillation, 1 second. So 2 seconds. Sometimes in the movies, the pendulum which is being shown, it is called a seconds pendulum because it's like that, or it's a name, specific name given to it. Speciality is that the arm length is 1 meter.
Okay. And what about the pendulums in the olden clocks? The pendulum clocks.
So that's just for the namesake. It's not a seconds pendulum.
Okay.
Seconds pendulum specifically, you have to be assured that the arm length will be 1 meter.
Okay.
The pendulum that we hang in our rooms sometimes, just to see the time, it is not a seconds pendulum. It is automated from within.
Okay.
For a seconds pendulum, you just leave it like this. You take it to any distance, just take it to any distance and leave it. It will start oscillating with a time period of 2 seconds only. It is fixed for it.
Okay.
But the pendulum which you purchase on the market, when you go to market also, you see pendulum clocks. So their arm length is 1 meter or less than 1 meter.
It will be less than 1 meter.
Yeah, 1 meter is quite long, and 1 meter will be like this big clock. So
Yes.
therefore, it's quite small. So it's automated actually from within to move at 1 second, one throw, and then back 1 second. It's automated from behind with batteries and all that. Therefore, battery kharab ho jata hai.
Yes.
And plus in modern situations also, due to some air resistance or something, it can't move. It will halt off or like that. So they're not seconds pendulum, but time period is 2 seconds for them. That's fact. Okay, so old time period was 2 seconds. Now what is the new time period given in the question?
2.5.
2.5 seconds. Achha, if I extend the class, you are comfortable, or you have to eat or lunch or something?
No, no problem.
Okay, so now it's the new time period is 2.5 seconds. So the time is gained or lost?
Lost.
Very good. So time lost. How much time is lost?
0.5 seconds is lost.
time lost is 0.5 second in how much seconds? 2.5 seconds.
Okay.
See, actually, when you see this new clock, when it is being heated, now when the, I mean, one oscillation will be, one full oscillation is like, say it starts from here. So it goes
Yes.
like this and goes back. So how much time is completed now? 2 or 2.5? 2.5.
2.5.
After getting heated, 2.5 seconds has completed, right?
Okay. Yeah.
So in 2.5 seconds, it makes like it goes back. So 2.5 seconds, in 2.5 seconds, there is a loss of 0.5 seconds.
Yes.
Okay.
Yeah.
So how much will be the loss in 1 week? So
This
see,
0.5 into
first you have to use unitary method. See, in 2.5 seconds, 0.5 seconds loss.
Yeah.
So you have to calculate loss in 1 second first.
Okay.
So it will be 1 by 5 if you carefully see. 0.5 by 2.5. Shall I do full calculation?
Yeah.
So in 1 second, the loss is 0.5 by 2.5, correct?
Yes.
This is the loss in 1 second. And you know how to cancel this or not? Like you can remove the dots
Points. Yes.
points. So one point up and down. So it's 5 by 25.
I want the 5 5 1 by 5.
1 by 5, very good. So in 1 second, the loss is 1 by 5 seconds. Now, how much will be the loss in 1 week? So you have to write on left hand side 1 second. So 1 week mein how many seconds are there? We have to find. Multiply that on the right hand side. Okay. Got it, na?
Yes. 360 into 20.
So this you do.
Oh, 60,480.
Was this the calculation you did? Check once. 1 by 5 into 3600 into 24 into 7.
Uh,
See, 1 week means this refers to 1 hour.
I calculated the number of seconds in a week.
Okay. How
And
much
now
is
I
that?
have to do it in 60,480.
Okay. 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 Go ahead then.
Now I have to do into 1 by 5.
Yeah. Okay. So that part you can do then at your home. Huh? No issues.
Yeah.
Just you have like in 1 week, these many seconds are there, na? Check once.
Yes.
Okay.
That I
Then
have done.
okay. Then calculation you can do peacefully in your home office. But this was the concept. So this much time is lost.
Okay.
Okay. So this is the question. Like so, like these questions can be asked. And similarly, it might have taken to Antarctica time period become 1.5 second. Find the time lost or gained in 1 week or 10 days or something like that. Okay.
Okay.
So like that also questions can be asked. Okay. So now let us come to the very essential thing. So this is basically the ending part. Conversions. If I'm not wrong. That was the last topic.
Yeah, it's the last topic.
So right.
Actually, relative density is the last topic, but we have already covered it.
Okay. Now write down conversions. So quickly copy whatever I'm writing now. I'll explain to you. SI millicentideci. This is the standard one. And ऊपर में डेका हेक्टो kilo.
Okay.
You have to remember it. Millicentideci, it's like that. And deca hecto kilo.
Like in our school, they've taught us a way to learn this thing.
Oh, what is the way?
Like it is King Henry died, and first is meter. So they take length. So meter. Mother didn't cry much. So next for weight, it is grandmother didn't cry much. And for liter, I think some name was given. I don't know. It was in second or third that
So for
answer.
this, you said King Henry died, mother didn't cry much for meter.
Yes.
And for
Yes.
gram?
Gram, King, it will come like King Henry died, gram will come. So grandmother didn't cry much, I think.
Okay.
Like that, they have made us something.
Yeah. So you understood, na?
Yeah.
So this is how. So now this will be applicable for everything actually.
Yes.
This is applicable for length also. It is applicable for mass also, for time also. Of course, for not time. I'm sorry. It's not. There is nothing like kilo time
Yes.
or hecto time. It's not applicable for time. But it's applicable for mass, length, volume. Okay, for these things it is applicable. My voice is audible, no?
Yes, sir, it's audible.
Mass, length, and volume. So these three things it is quite much applicable. Now you see, so this is the SI unit. Say for example, we are taking one case for length. So SI unit say meter for length we are taking. Okay. Now decimeter means what? 0.
1 by 10 meter.
Yeah, very good. So 1 by 10 meter you can say. Similarly, centimeter
0.01 or 1 by 100.
1 by 100, yeah. And likely millimeter means 10 to power minus 3. Okay.
Yeah.
Similarly, upper mein deca means 10 meter. Hecto means 100.
1,000.
Kilo always means 1000. So like that. So like that for everyone it is applicable. Either it be mass, length or volume. All right.
So one doubt, in mass, SI unit is kilogram, right?
Yes.
But we can't get kilogram in the center, we take grams.
Yes, we take grams, correct. But kilogram is the SI unit. Yeah, no problem.
Okay.
Because generally kilogram is a more convenient method to use. That's why we use it. Like we know MKS system, it's meter,
Kilogram and second.
but kilogram comes here, right?
Yeah.
So it is defined as per the practicality. Okay, because gram would be too less. If you would have to tell, I mean, I don't know, like say for example, my weight is 60 kg. If you have to tell my weight, then it's 60,000 grams. more convenient to say 60 kilo.
Yes.
Got it? And if the kilometer would have been a standard measure, then my height would have been like a 0.00 something kilometers. So tough to tell.
Yeah.
So SI unit is defined as per the practicality.
Okay.
Okay. So now we'll quickly let me see what is there in your book. I hope I'm sharing my screen. Yes, I'm sharing my screen.
Yes.
Let me first see what kind of calculations are given here. In the book. Okay, I'll only give some calculations and then we'll try to solve it. So I'm writing some examples. Say 10 kg meter per second converted to CGS. Okay, you can start doing. I'm writing 3-4 questions.
So is the first one 100?
Achha, answer you are asking.
Yeah.
It's 10. 1 kilogram to how much gram? 100. 1000, sorry. And 1 meter in centimeter is 100 centimeter.
Yes.
And second is second.
Second.
You got it? How to solve?
Okay, got it. I have to do like that. Yes.
Centimeter will be second, like that. So it is coming out how much? 10 to the power 7 gram centimeter per second.
Okay, got it.
Per second, you don't write SCC, just write S.
Okay.
First one is clear how to do?
Yes.
Okay, so if first one is clear, wait, you solve the fifth one then. Okay, no problem, you can solve the second one also. Like I'll show you one more thing before you do this conversions. First part is clear now how to do.
Yeah.
We
Clear.
just keep putting the values of this accordingly. And one more thing I'll just show you here. See, say for example, there is a square whose area is 25 meter square. I have to convert it in centimeter square. Okay.
Yes. Yes.
So how I will convert, see, if you see this 25 and what is meter square? It is 1 meter into 1 meter basically. Okay. Then I get meter square. So what is, how to convert it? So this is 25 and 1 meter is 100 centimeter multiplied by 100 centimeter. 2 times centimeter, so centimeter. You got it?
Yeah. So 25 into 10 to the power 4.
Yeah. Or more precisely, it is written as 2.5 into 10 to power how much?
5.
5. Very good.
By 2.5.
Generally, this is called scientific notation in which you keep behind dot. I mean, after dot, there should be something. Usually, they put it like that.
Okay. So the second one I should write it in scientific notation only.
Not mandatory. I mean, I just told this so that by looking at the options, you can understand.
Okay.
So that tomorrow you're not confused with the options. Just to give an example, I wrote it. You can write in any format. So this meter square portion was clear now? If
Yeah,
it would
sir,
have
clear.
been, if it would have been meter to the power 4, then that many times centimeter will come. 100, 100, 100, 100, 4 times.
Okay.
That was the point to understand powers. Okay, go ahead, fast.
So here I should write 0.05 into 10 to the power 4, or can I write 5 into 10 to the power 2?
Both you can write. 5 into 10 to power 2 looks better. 500 also you can write, no problem. Just 500 centimeters, so that's it.
Yeah. So how do I do the third one? I didn't understand.
Okay. I had told you that 1 Newton is 980 Dian.
Yeah.
You
Yes.
just put it. Got it?
19.6.
I also don't know. Let me check.
I calculated, I got 19.
It's, 19.6, yes. Thanks. In case you ever forget, you can change 1 Newton to 1 kg meter per second square
Oh,
and put all those meter in centimeter. Okay, like that, kg into gram, like that you'll get. But yes, G value you have to put as 9.8 there.
what is a hectare?
Hectare, yeah. Hectare comes from hecto.
100 meters square, is it?
See, what is the relation here? You check. Hectare comes from hecto. This much is clear.
Yeah.
So these two portions are there, no?
Yes.
So so basically this is comparison of area.
Hmm.
So this is meter square. So here it's like hecto square. It's called hectares.
Okay.
You are understanding how to compare. If it's
Yeah.
meter square, this also should be in area only.
Yes.
So 1 meter is 10 to the power minus 2 hectares.
2 hectares. Okay.
So meter square will be 10 to the power minus 4 hectares.
Okay.
Got it?
Yeah. So is it 2.5167?
Yes. So fast, fast, fast. The battery is dead.
Yeah.
Done. Fifth one.
100.
100 into 5 by 18, 20, 100. Yeah. The last two. Okay, this one you have to remember. It's a very important thing. 1 meter cube is equals to 1000 liter. So meter cube is a unit of what? Length,
Meter
area, or
cube.
volume?
Length.
Ah, 1
Area.
meter.
Area.
Ah,
Volume.
ah,
Volume. Meter is length and
yeah,
cube is volume.
yeah. Meter square will be area, and 1 meter cube will be volume. Okay.
Yeah.
So what is the equivalent? 1 meter cube is in terms of liter is 1000 liter. It's also very important conversion. So here is 27 centimeter cube will be how much liter?
27,000.
Hmm? Check once. It's centimeter cube beta.
Centimeter cube. Okay. 6. 7,000,000. 27 lakh.
Okay, see how we will do this. Firstly, I don't know relation between centimeter and liter.
Okay.
So what I will do, I will change this in meter cube first.
Okay.
So this is 27 and once like this is centimeter cube. So it
Into
is 10
100.
to power minus 2
Yes.
is 1 meter. 1 centimeter is 10 to the power minus 2 meter.
Yeah.
This is cube of it.
Hmm.
Okay, so this is 27 into 10 to the power minus 6 meter cube. You got it?
Yeah.
Yes. So now, and now one meter cube to liter is, so 1 meter cube is 1000 liter. So it is 27 into 10 to the power minus 6 into 1000 liter. This is the answer. 10 to the power 3. So that is 27 into 10 to the power minus 6 into 10 to the power 3. Okay. This much is clear?
Can we directly write 27 into 10 to the power 3? No,
Minus 3.
minus 3. Yes,
हाँ,
minus.
yeah, yes, yes. Directly we can write. I like मेरे को पता नहीं था, you know, so I was writing in detail.
Okay.
Okay, it's clear.
Okay, clear.
These many liters or 27 ml milliliters.
Uh,
So to make the question difficult, it would have been written here milliliter. So always remember that whatever units you know, say centimeter, so standard you have to convert it into meter, milliliter, then find out in liter, and then do the necessary needful things.
okay.
So whenever the conversions are done, whatever quantities we know about, that we first convert, and then we try to adjust the final equations. Clear?
Yeah, clear.
So I hope I have covered everything.
Yeah.
So like that, you have to convert these things. Yes. So I guess now you can solve all the solved examples once. Whenever you
Yeah.
get doubt, you let me know. Like 1 ton. 1 ton is 1000 kg. So there will be certain things which can't be covered everything in details. But while solving, you will understand. Okay? These things will come up.
Okay.
So you can solve now everything. I mean the entire
Okay.
exercise also. And wherever you get it out, you can just like, okay?
Okay, I'll solve it, and any doubts, I'll let you know.
Yeah. So you solve question by question, okay? And while solving, you don't solve it like very peacefully. Like I'll tell you how to solve it, and you have to follow this mechanism strictly.
Okay.
Like say, for example, if you're solving fill in the blanks, how many questions? 15 questions, right?
Yeah.
So you have 5 minutes to solve it.
Okay.
So for fill in the blanks, 1 minute means 2 questions. You can write it down somewhere if you want. Fill in the blanks, 2 question in 1 minute. That is required. True, false. Okay, 1 minute, 1 minute per question can be given, but that is actually a lot, to be honest. Half a minute per question, okay? Same for true, false.
Half a minute, I think, is enough to write a word.
Yeah, actually, sometimes, you know, in fill in the blanks, questions can also be given, calculative questions.
That
But actually, still half a minute you can take,
yeah.
sufficient enough. And match the following, say 5 subparts. So you can take like 2
1 minute,
minutes.
2 minutes.
1 minute if you can do, very nice. You can take 1 minute. Actually, questions are pretty easy, I'm saying.
Oh, what is that symbol in the C question? Is it millisecond?
It's micro. It's called mu.
Micro.
Mu. MEW, mu. Not sorry, it's meow. I mean, MEU. Mu. Sorry, MEU. Whatever it is, you understand? It's a mu. MEU.
Yeah. Yeah.
So it's called mu. It's pronounced as micro.
Oh,
It means 10 to the power minus 6 seconds.
okay.
Micro is always used for 10 to the power minus 6. Nano, 10 to the power minus 9. Okay?
Yeah.
You're writing it down now?
Yes.
Also write down also angstrom. ANGSTROM.
Angstrom.
Angstrom. It's 10 to the power minus 10.
Yeah.
And that much is frequently used. Yeah. Okay. Further, I think everything is fine. So multiple choice questions. Okay, multiple choice questions. One question, 1.5 minutes. Like that, you can calculate the total number of questions. See, when you're solving an exercise, solve entire exercise in one shot as a test. Say 15 questions are there, multiple choice. 15 multiplied by 1.5, 22.5. Right? So you can take 25 minutes you can take and solve all 15 questions in one shot. Like take your copy, take a copy, one option number this, two option number this, and have a clock. After it gets finished, immediately stop it, check your answers, then whatever is remaining, solve it.
Yeah.
So you will get an idea of how much you can score, and the objective type will get really practiced in that. Do it honestly, it will really help you.
Yes.
And numericals also you have to do it in the same way. 10 questions are there, you can take like 2 to 3 minutes per question.
Yeah.
Okay, conceptual questions, they are not to be solved actually. By looking, you can answer, but still you can take again 2 questions, like 2-3 minutes you can take. By looking at the level of the questions, you yourself can judge. Usually it is 20, 20, 20, 60. They get how much? 3 hours time, 3 minutes. Yeah, 3 minutes per questions, 2 to 3 minutes you can take in between something as per
Oh,
the level of the questions.
yes.
You can take 3 minutes initially, no problem. And in that way, you have to solve the questions. Clear?
Yeah, sir. Sure.
All right. So we'll end here. Thank you very much. So by next week, you complete all the exercises.
Okay.
And you can ask me doubts in between. Okay. Thank
So next class Tuesday.
you. Tuesday, yeah.
Okay. Same time.
Same time, yes. And if in between, same time means Tuesday. Okay, morning slot. Possible. Possible, yeah.
Same time. Okay. Sure.
Uh, and if in between I get some questions, then I'll just write down to you and send it to you. You can try to solve that also.
Okay. Okay.
Thank you.
Thank you, sir.